Now let us proceed to question number 4. Evaluate this equation using 3-point Gaussian quadratic formula for the given numerical values uh, of weights and abscissas. So in this question, first of all, we have to convert this integration, that is from 0 to 1 to in the range of -1 to 1 to apply Gaussian quadratic formula. So what we can do is, in place of fx we can write it as f of b minus a upon 2 into t plus b plus a upon 2. This formula will change it in the range of -1 to 1. So that's what I have done here. As you can see, phi of t will be -1 to 1 f of t plus 1 upon 2 dt. Here b equals to 1 and a equals to 0. So b minus 1 upon 2, it will be 1t plus 1 by 2 upon 2, b minus a upon 2, right? So it could be written as t plus 1 upon 2. So if it's t plus 1 upon 2, we put in place of x, so it will become t plus 1 whole square upon 4. 4 goes in the numerator and we have taken the LCM, so this will be our final equation. Now according to Gauss-Lenglen quadratic formula, it is -1 to 1 pi of t equals to w1 pi 1t plus w2 pi 2t and so on. So here w1, t1, w2, t2, w3, t3 values are given. So we have just put in the values. So phi 1 of t will be w1 into phi of t1, and on solving we get the value of plus 0.505005. Similarly, we have put the value of w2 here and t2 here, and similarly in case of w3 here. And after that we have just find the sum, which is 1.57744650, and this is our answer. Now let us proceed to question number 2. Derive Simpson rules using Newton-Cotes formula. So according to Newton-Cotes formula, its formula is I equals to nh summation of I equals to 0 to n yi ci of n, where ci of n is 1 by n integration 0 to n li of u du. And now what is li? Li is u minus 0 upon I minus 0 into u minus 1 upon I minus 1 and so on. Okay, so for Simpson 1/3 rule, we put n equals to 2. When we put n equals to 2, it becomes I equals to 2h summation of I equals to 0 to 2 yi ci of 2. So I equals to 2h y0 c0 square c0 of 2 plus y1 c1 of 2 plus y2 c2 of 2, right? Now we will find y0 y1 c0 c1 c2 1 by 1. So in this, c0 will be equal to what? 1 by 2 integration of 0 to 2 L of u du, right? So we have just put the value of from here to here. So c0 of 2 equals to u minus 1 into u minus 2 upon 0 minus 1 into 0 minus 2, right? So in this basic case, let me tell you, if I is equals to 0, so we will hide this I equals to 0 and takes rest of the sum. If I is equals to 1, we will hide this I equals to 1 and we will use I u minus 0 upon I minus 1 and u minus 2 upon I minus 2, right? So in this case, as we can see, C1 is 1. So we have used what, u minus 0, that is u into u minus 2 upon 1 into 1 minus 2, right? Yeah, 1 minus 0 into 1 minus 2, right? And now after finding this, we have just done the integration, and we have solved by putting the limits from 0 to 2, and we get C0 as 1 by 6, right? Now we have similarly we have find a C1 and we have find C2. I have tell you about how to find the Li, which is the most confusing part in this question. So when we find the C0, C1 and C2, just put in this equation and we will get our answer, that is I equals to 2h y0 into 1 by 6 plus 4 by 3 y1 plus y into 1 by 6. And on further solving, it will compose to I equals to h by 3 y0 plus 4 y1 plus 4 y3. Okay, this is the derivation of Simpson one-third rule. For Simpson CA2, we can put n equals to 3 and solve it again. Right. So this was our fourth question. Now we will proceed to question number 5.